Thank you, Dima. Mr. Rasmussen, can you please give us your presentation, and after that we will have time for questions from audience. Thanks.
Hi everyone. Again, smart mining, digitization in equipment, technology, and industry. I'm going to get a little bit more specific of how to do it than compared to Dimitri, but it's certainly exactly down the same line of path that he just laid out for you guys. So I'm from FLSmidth, and in FLSmidth, then digitalization is an important step for our future development. And what is it that we mean when we say digitalization? It is that we increase productivity for our clients through digitalization. So shortly, FLSmidth is a fairly large and global company. We are 13,000 employees worldwide. We are present in more or less every region of the world. I had to do accounts. The company is 136 years old today. So we've been in the business for a long time. And we are the fully global partner with regards to delivering solutions from the entire process. It's a one-stop shop. All right. So before I get into how it looks like, I would like to outline what it is that you can achieve with digitalization when you implement it on equipment level. And even before I go there, I want to follow up a little bit on the local municipalities, what their focus was, that they're bringing the mining business to their region. And I really want to emphasize also that when we're doing that, we are creating new jobs. The mining companies are creating new jobs, but it is the region's responsibility to ensure that the jobs created are also first-class jobs. And you can do that through digitalization. So removing operators from an unsafe environment, ensuring that all the conditions are met and you have a safe environment. So FLSmidth has a large product portfolio. I'm going to focus on two products that I'm going to show to you today. And I'm going to start a little bit backwards with what you can achieve. So basically, from the beginning, by removing operators from the environment, you can significantly boost the performance of stacker reclaimer machinery. So typically we see that by removing the operators and turning it into fully autonomous operation, you can boost the capacity, the nominal capacity, by up to 20%. At the same time, it doesn't come at the cost of extra wear and tear. What you're doing is that you're facilitating and streamlining your production facility, which means that you significantly reduce the flow rate variations in your bulk handling equipment, and that means that you have a significant reduction of wear and tear on your equipment. Alongside with removing the operators, you also ensure that you have a safe environment. We have, with our unmanned operation, a perfect track record of zero collisions of equipment to equipment or equipment to piles. So, and for the other product, for train loading, train unloading, car dumping, you can boost or reduce the loading time by up to 10%, which means basically the same operation you have today, you apply digitalization, smart monitoring, and you can significantly improve your throughput capacity of existing equipment. So why should one use centralized or unmanned operations? Well, the problem is, in general, semi-automatic systems, manual operated system, they always rely on human input. They need someone to assess the situation or guide the system in order to make the process flow. That means also that whenever you have a human or an operator interference, then you will have overutilization or underutilization. And both of them are equally bad. So if you have overproduction, overutilization, that means that it comes at the cost of wear and tear on your equipment. If you have underutilization, that basically means that you are not running the equipment very effectively. So the first step is eliminate the varying factors. So if you could do that, you can stabilize, you can optimize, and then finally you can maintain a high production rate on your equipment. But how do you do it? It's not that simple to remove operators from a changing environment, especially when you're working with large quantities of material that fluctuates. It may be in one position one day, it may be a different section another day. So I will go through the core technologies that we're using in order to leverage digitalization within the mining industry. So we use and rely on heavy-duty industrial laser scanning technology. We use high-precision global navigational satellite system, basically GPS or GLONASS or Baidu if it's in China, which provides a very accurate and unmatched direct and absolute measuring position. Then we combine those two, so when we use a scanner, you can scan your environment, and when you link it up with the position technology with the GPS, it's a matter of algorithms. So we run it on-edge computing, so the amount of data that you get from a laser scanner or a 3D environment is enormous, and that also means that you cannot directly send it up to the cloud and just rely on cloud processing. You rely on real-time data, which means that you have to do that on edge computing. So the laser scanner, we use it for our mobile equipment, so for our stacker reclaimers. So by mounting a laser scanner on top of the machine, it provides a fully 3D or 360-degree view around the machine, which provides a mathematical and topographical map for our processing to use when it calculates how the machine should operate. The laser scanner is an eye-safe Class 1 laser scanner, which means that there's no requirement to a certificate. You can implement it in any environment. It has an unmatched accuracy and distance measurement. So it has no problems in penetrating dust clouds either, and it provides, in many cases, a much better visual than what you do with a human operator or with your own eyes. So the other part that I was mentioning is the GPS solution, which is, it is still, when you're talking about mining equipment, it is state of the art, but it's not an unproven system. Since the Americans launched their system in, I think it was 94, and the Russians followed shortly after, there has not been a single day of a global outage of the GPS system. It is fully reliable, and to many occasions, it has a much higher availability than traditional automation sensor technology. It has an accuracy of plus minus 1 centimeter, so it's far more than sufficient to use on these large machines where a bucket is typically 1 meter to 1.5 meters in dimensions. So for our train loading technology, again, the key concept is that we need to know exactly the process itself. So for the stacker reclaimer technology, the process that we're trying to reach is the material. It's the stockyard. It's the content of the material which is about to be reclaimed. For a train loadout station, it's a little bit more simple. It's a batch loading process, which means that the material comes to you. The rail cars come to you. So by doing that, we can utilize a little bit more simpler technology. It's a short-range laser scanners. Again, they're Class 1, they're eye-safe protected. And they have more or less the same accuracy. So they have the advantage that they're mounted close to the process, and so they do not have the same range requirements as an advanced LiDAR laser scanner. But by doing so, by measuring many thousands data points, then you can optimize your process, which means that you're not running on best known knowledge, you're running on actual scan data. So you can fully remove the operator interactions and rely on that the data that you're gathering is not secondhand information. It is not a loading schedule, load report that was handing over from the what's called the traffic authorities or the railroad authorities. You actually verify it by scanning the incoming wagon and verifying if that is matching. So I have a small example here from our software. It might be hard to see, but the train loading process is not exactly a Formula 1 business. But what you have here is that first the train are being dragged through our laser scan array. So initially, the assessment will be that it identifies, and as the wagons move through the process, they get identified. They get verified. Is it a locomotive? Is it a type A, B, C wagon? What is it? How much content goes into this wagon, etc. So the second step is the adaptive control. So you monitor exactly the speed of the train. You verify that you start loading as per a non-linear dynamics, and ensure that you have an optimal loading profile which matches the surroundings. Then finally, you do a load verification. So once you load it, you actually also verify the content of the wagon. Is the weight distribution okay? Is the volumetric optimization of the wagon, is it okay? All of this is possible through digitalization. So again, we use it directly on the equipment, but the data we present it to a corporate enterprise system. So if that data is also usable when you're producing the actual load list, which it is, then you can pass it on to the next process in line, and they can enrich the data. So again, for the initial process, for the control of the equipment, we use edge computing. But for the second-hand process, which is not so time-critical for creating the loading reports, we can, it is typically shifted into a cloud service, or to the ones that are a little bit more concerned about cybersecurity, to an enterprise cloud, which is locally for the owned company. So for the other part we're talking about, for the 3D laser scanners and for the stockyard environment for these stacker reclaimers, the technology is more or less the same. We combine the laser scan data that you have from each one of the laser scanners in the environment. You may have several pieces of machinery, which means that whenever they see a new section of the stockyard, they update it and they send it to the server. That means that you constantly have a real-time inventory accounting. That data you can pass on to the business intelligence. You can use it for scheduling and planning your operation. So as our focus is primarily the fully and optimized operation of the equipment itself, but that doesn't mean that the data is only valid for us. So we pass it on to the company ERP system so that they can make sure that they can use that data and once again, enrich the data. So if we, on the other hand, is also provided during stacking operations the knowledge of what is the content of what we're stacking, we can team up with the sampling station, which is a different entity of FLSmidth also. And not only do we keep track of the contours of the pile, but also the content of the pile. So you, at any given time, you can tell if you're reclaiming this section, you know exactly what goes onto the belt. So that also means that you are provided much better means for protected of pile contaminations with the autonomous system. It also ensures that you have fully uniform operation. You can reduce the environmental impact by ensuring that every operation procedure are met, so you do not have excessive dust emissions. And I can tell you, if you've been to a mine where they are not very cautious about that, you'll find several square kilometers around the mine in the same color of the product that you're mining. So again, we utilize the latest technology with regards to either edge computing, enterprise clouds, or cloud services. I have a small example here from a stockyard, which is 40 million tons per year. They have 7 machinery. For simplicity, I've shown it as a 2D topographical map. This is a time lapse taken over several days, but it's to show you exactly when you have enough data and you utilize it, you can provide first-class jobs in an environment which is traditional, a difficult or dirty business, or maybe not business, but environment. So to summarize, that in FLSmidth, we use digitalization as a catalyst to increase productivity for our client. Thank you.